Good morning, student. In our previous lecture, we discussed with you Avogadro's law and the mole. Today, we start with the concept of a mole concept in solution, which basically in many books is given by the name of a volumetric calculations. Before I start discussing the volumetric calculations or the terms used in volumetric calculations, we must be aware of the word solution. Solution. What is solution? Solution is a homogeneous mixture of. It is a homogeneous. It is a homogeneous mixture of two or more than two components. Homogeneous mixture of two or more than two components. Am I clear? Homogeneous mixture of two or more than two components whose concentration can be varied within a certain limit. Whose concentration can be varied within a certain limit. Can be varied within a certain limit. So it is a homogeneous mixture of two or more than two components whose composition can be varied within a certain limit. Remember, when I talk about the solution, if it is consisting of only two components, it is called as a binary solution. If it contains three components, it is called as a ternary. If it contains four components, it will be called as a quaternary solution. In our syllabus of a class 11th and 12th, we have a binary solution in the syllabus. When I talk about the binary solution, there will be two components of the solution. This will be solution, will be having two components. One will be solute and another component will be solvent. How many components are these? Two. So what type of solution it will be called as? It will be called as a binary solution. So what is a binary solution? A solution which is consisting of two or more than two components whose composition can be varied within a certain limit. Suppose it consists of two components, one is solute and one is solvent. It will be called as a binary solution. Now if the question is asked, what is solute? Solute is that component of the solution which dissolved in a solvent. So solute is that component of solution. It is that component of solution which dissolved in solvent, which dissolves in a solvent. Am I clear? Solute is that component of the solution which dissolves in a solvent. Now what is solvent? Solvent is that component of the solution which have same state of aggregation as that of the solution. So solvent is that component of a solution which has same state of aggregation, which has same state of aggregation, same state of aggregation as that of the solution, as that of solution. What do I mean by this? Most of the people think that in the solution, one which is present in the larger amount or present in a larger extent is a solvent. But let me explain you correctly. What do I mean by solute? What do I mean by solvent? If I say we have a 40% sugar solution. If I say we have 40% sugar solution. 40% sugar solution means it contains 40 gram of sugar, and if the solution is in water, it will have 60 parts of, in fact I must say 40 parts of sugar and 60 parts of water. Now over here it is not a problem. How many parts of sugar are present? 40. How many parts of solution are present? 60. What will be the form of a solution? It will be in the liquid state. What is in the liquid state over here? Water. So water will be a solvent. Am I clear? Solution is in the liquid form. Water is in the liquid form. Sugar is in the solid form. They have a same state of aggregation. So water will be a solvent and sugar will be a solute. Sugar over here will be solute. Am I clear? Now see another example. If I say 60% sugar solution. If I say 60% sugar solution, it will be having 60 parts of sugar and 40 parts of water. Is it clear or not? Now here sugar is present in the larger extent. Water is present in the lesser extent. So, many people will say, or in fact will get confused, because they say whatever is present in the larger extent is a solvent. But just see over here, it is in the lesser extent. But then it is in the liquid form. The sugar solution also is in the liquid form. These this water and the sugar solution has the same state of aggregation. Aggregation means form. Both are present in the same form, that is in the liquid form. So it will be considered as a solvent, it will be considered as a solute. So solvent is that component of the solution which have a same state of aggregation as that of the solution. Sometimes both may be present in the equal amount. So suppose if I say 50 parts of alcohol and 50 parts of water. In that case, the component which get dissolved is a solute and the component into which the solute get dissolved will be a solvent. Am I clear? Now after this brief discussion of a solution, we come to the major part of the lecture of the day. I have to express the mole concept in solution. What do I mean by this? I mean concentration in solution. Concentration in solution. What does it mean? I mean when I dissolve solute into solvent to obtain solution, what are various ways of expression of concentration of solution? So we will discuss concentration of a solution. So concentration in solutions. What do I mean by concentration in solution? When a solute is dissolved in solvent, what are various ways by which the concentration of solute in solution can be expressed? First way of expressing the concentration of the solution will be molarity of the solution. First way is molarity of a solution. Now this molarity of the solution is given by the symbol capital N. How do we define it? It is defined as number of moles of solute dissolved in a liter of the solution. Am I clear? So how do we define molarity? It is defined as the number of moles of solute present per liter of the solution. Number of moles of solute upon volume of the solution in liters. Upon volume of a solution in liters. So number of moles of solute to the volume of solution in liters. If I represent number of moles of solute by the symbol N and the volume of the solution in V, what will be the unit of this? Mole. This is in liter, so this is mole per liter. This is molarity of the solution, written by capital M. So molarity of the solution will be equal to number of moles of solute present in a liter of a solution. It means concentration will be expressed in the terms how many moles of solute is dissolved in a liter of the solution. Just see over here. What is number of mole? This will be equal to given mass upon molecular mass. We all know the formula. So we can write down this formula of molarity as given mass of solute upon molecular mass of the solute to the volume of the solution in liter. What is this W? It is given mass of solute. Given mass of solute. What is this M? This is a molecular mass of solute. And V is the volume of the solution in liters. V is the volume of solution in liters. Am I clear? Now if volume is in milliliter, then molarity of the solution will be given as W upon M into V into 1000. I think I shall be very clear. Is it clear? What is the first way of expression of concentration of the solution? Molarity. How do we define it? As number of moles of solute upon volume of the solution in liters. Formula N upon V. If moles are given and the volume in liters is given. What is mole? Given mass upon molecular mass. Putting this value over here, molarity will be equal to W upon M into V. So number of moles of solute present in the liter of the solution will be called as a molarity of the solution. Now this V, if expressed in terms of milliliter, then W upon M into V into 1000 will be the formula. Think how I have obtained the multiplication by 1000. Yes, when this is in liters, so this must be in the kilogram, the mass will also be converted into the gram. Now, let me explain to you this concept by giving one example. Suppose the question is, calculate molarity of if 4 gram of sodium hydroxide is dissolved in 500 ml of water. Question is clear? Calculate the molarity if 4 gram of sodium hydroxide is dissolved in 500 ml of water. Molarity formula will be W upon M into V into 1000. What is the given mass of sodium hydroxide over here? 4 gram. So this will be equal to 4. What is the molecular mass of sodium hydroxide? 40. How? Sodium hydroxide. This will be 23 plus 16 plus 1. It will come to be equal to 40. 4 upon 40. What is the volume in milliliter? 500 multiplied by 1000. Am I clear? We solve it up. So what is coming? 1 by 5, unit of expression capital M. So this will be equal to 1 by 5 molar or 0.2 molar. Am I clear? This is how we we calculate the molarity of the solution. Now, as far as the expression of the molarity is concerned, if you write down a 1 molar solution, it means 1 mole of a solute is present in the liter of the solution. Am I clear? If you say decimolar, it can be expressed as decimolar. It can be expressed as centimolar and so on. Am I getting clear? So when I say, suppose if I say 1 molar sodium hydroxide solution. What do I mean by this? It means 1 mole of a sodium hydroxide is dissolved in 1 liter of the solution. 1 molar means equal to gram molecular mass. So it means 40 gram of sodium hydroxide solution is present in 1 liter of the solution. 40 gram of sodium hydroxide is dissolved in 1 liter of the solution. So if I write down 1 molar, it is this. If I write down M by 10, it means it is decimolar solution. M by 10 means 0.1 molar. So this is decimolar solution. Am I clear? These are the way by which the concentration can be expressed. If I write it as, now what do I mean by this 0.1 molar? It means 10th part of the 40 gram. That means 4 gram in a liter of the solution of sodium hydroxide. Am I clear? If I say M by 100, this will be called as centimolar solution. What do we call this solution? Centimolar. It means 0.001 molar solution. M by 100 means 0.01 molar solution. I think I shall be clear. If I say millimolar, 0.001 molar solution. So one way of expressing the concentration of the solution is molarity. What is molarity? It is the number of moles of solute to the volume of the solution in liters. Molarity will be given as N upon V, mole per liter. Formula will be W upon M into V. Suppose if the volume is in a milliliter, then what will be the molarity of the solution? It will be W upon M into V into 1000. Am I clear? Molarity can be expressed as solution can be, if solution is written as 1 molar, it means gram molecular mass of that solute is present in the liter of the solution. If I say M by 10 molar, it means molarity is 0.1 molar. It is called as a decimolar solution. If I say M by 100, it means 0.01 molar solution and will be called as a centimolar solution. So first way of expressing the concentration is molarity. Now the numericals on molarity can be framed in various forms. I'll try to give you the final touch, how to calculate how to solve the various numerical problems related to molarity. Just see over here, in the form of a note, I'll try to explain to you how to solve the numerical problem. If in a numerical problem, it is given percentage mass of a solute and the density of the solution is given, then how to calculate the numerical problem? If it is given X% of the solute is dissolved in, if in the question it is given, if X% of solute is dissolved, mean to say if X% of the solute is present in solution having a density d gram per ml, then always remember molarity of the solution will be equal to X% into D into 10 upon molecular mass of solute. I think I shall be very clear. If in a question it is given X% of the solute is present in the solution having a density d gram per ml, then you will calculate the numerical problem directly by applying the formula. Molarity will be equal to X% into D into 10 upon molecular mass of the solute. Suppose if I say or give you a numerical problem to calculate the molarity of a nitric acid solution, which suppose if I write down the numerical problem, calculate the molarity of nitric acid of 69% nitric acid solution. 69% nitric acid solution having a density, suppose the density is given as 1.19 gram per ml, having a density 1.41 gram per ml, then solution will be, molarity will be equal to X% into D into 10 upon molecular mass. What is the percentage given over here? 69%. What is the density of the solution? 1.41 into 10. What will be the molecular mass of a nitric acid? It will be 63. Am I clear? You solve it up. On solving, you will obtain the answer as 15.44 molar. I think I shall be very clear. So, two numerical problems are clear to you. This will be the molarity of the solution. So, if in any numerical problem, the density of the solution is given, percentage mass of a solution is given, molarity can be calculated by use of a formula. Molarity will be equal to X% into D into 10 upon molecular mass of the solute. What was molarity? Number of moles of solute present in the liter of the solution. If volume was in ml, molarity of the solution can be given by the formula W upon M into V into 1000. Am I clear? What do I mean by the word 1 molar? It means 1 mole of a solute is present in the liter of the solution. Mean to say gram molecular mass of the solute is present in the liter of the solution. If I say M by 10, it means 0.1 molar. If I say M by 100, it will be centimolar solution. If I say M by 1000, it will be millimolar solution. Is it clear to you? Yes or no? Good. Now, molarity of dilution. Another way of expressing the concentration of solution will be the molarity of dilution. If suppose we have a solution of any component whose molarity is given, and we want to make the another solution from the given solution of a desired molarity, then how do we prepare that solution? So we will be having a formula, and that will be the molarity of a dilution. How to obtain the molarity of dilution? Just see over here. Molarity of dilution. This is one way by which in labs we prepare the solution, molar solution given for the volumetric calculations. So molarity of dilution. Formula for molarity of dilution will be M1V1 will be equal to M2V2. M1V1 is molarity before dilution. M2V2 will be the molarity after dilution. Am I clear? Suppose in the laboratory we are provided with certain strength solution of a HCl. Let me say I have got over here 18 molar HCl solution. Suppose, what do I mean by this? A molar solution will be given. From here we want to prepare a strength of a solution which we want to give to this solution. Suppose we are given HCl solution. And suppose standard molarity of HCl is 18 molar. Into V1. From here we want to prepare a solution for volumetric calculations to the student in the laboratory. Suppose if I want to prepare 0.1 molar solution of HCl, I want to give to a question to the student of a 0.1 molar. Now my question is, what volume of this standard HCl solution is required to prepare 0.1 molar solution if my requirement suppose is 1 liter. 1 liter means 1000 ml. Am I clear? So from here I will calculate the V1 volume. And how will I calculate? This will be 0.1 into 1000 divided by 18. On solving it out, it will come out to be equal to 5.5 ml approximately. This will be 5.5 ml approximately. Am I clear? It means if I want to prepare 0.1 molar solution of HCl from a given 18 molar solution of HCl, I will take 5.5 ml of HCl of this, a solution which has been provided in the lab, plus 994.5 ml of water will be added. So if I take 5.5 ml of this and 994.5 ml of water, I will be able to prepare the solution of 0.1 molar solution of HCl, which I will be giving to the students for volumetric calculation or for the titration exercise. This is how the calculations are made for the volumetric calculation. When you come to the lab and we physically do the practical, might be possible I may show you the practical over here again in the virtual class, but this will become a practical work of yours. And of course, it is also included in the theoretical section. So in the very first chapter we are explaining to you how to prepare a molar solution. When we provide you in the laboratory this solution of a particular strength, how do we prepare it? We purchase from the market HCl. We calculate its molarity because the strength over there is given in that case. From the strength calculation, we calculate the molarity of the solution. We very well know what question we want to give to the student for the work in the laboratory.